This is section 7.2, day 2, applications. The amount of water in a storage tank in gallons is modeled by a continuous function on the interval 0 to 7, where t is measured in hours. In this model, rates are given as follows. First, the rate at which water enters the tank is f of t equals, well, this function. So this is enters. And it's gallons per hour for 0 to 7. Second part, the rate at which water leaves the tank is g of t, and this is a piecewise function, and that's where you see these horizontal lines. Gallons per hour. The graphs of f and g, which intersect at t equal 1.617 and t equals 5.076, are shown in the figure above. At time t equals 0, the amount of water in the tank is 5,000 gallons. A. How many gallons of water enter the tank during the time interval 0 to 7? So we have letter A. Now we're looking at enters the tank and only enters the tank. So we need to integrate from 0 to 7 of f of t dt. And for the sake of time, I've already put that function into y1. So there it is into y1, and the next two equations are the next problem. So we're just dealing with this function right here. So we'll go math number 9, and we're integrating from 0 to 7. And variables, y variables, and function, y1, and this is with respect to x. So how many gallons of water enter the tank during the time interval? And it says round your answer to the nearest gallon. That's equal to 8,263 gallons. B, for 0 to 7, find the time interval which the amount of water in the tank is decreasing. Give a reason for each answer. All right, well, the rate at which the water's entering, or, the rate at which the amount of water in the tank is changing is equal to, that's equal to f of t minus g of t. F of t is how much enters, or at the rate at which the water enters, and g of t is the rate at which the water leaves. Find the time of the water tank is decreasing. So when g of t is greater than f of t, then the water will be overall will be leaving the tank, and so that happens from 0 to this point right here, 1.617. So 0 to 1.617. And then the line is above the curve from 3 to 5.076. So 3 to 5.076. Now, how would I know that overall the water is leaving? G of t is greater than f of t, and that's a greater than sign. Greater than. Yeah, give a reason for each answer. C, for 0 to 7, at what time t is the amount of water in the tank the greatest? To the nearest gallon, compute the amount of water at this time and justify your answer. Well, let's do the endpoints, 0 and 7, and we'll also need when this rate changes from positive to negative. And that's going to happen here because f of t will be bigger than g of t. And then after 3, g of t is bigger than f of t. So that means the overall rate, this, went from a positive to a negative across 3. And that's when you find maximums, when the rate or the derivative goes from being positive to negative. So when t is 0, there are 5,000 gallons. And that's given right here. The initial amount is 5,000. Now we need to get to 3. And so we're going to integrate from 0 to 3 of f of t. That's the amount that enters. And then we have to minus 0 to 3 of g of t, but that's just a rectangle. We're integrating here, so we're finding the area under the curve. So we want all of that area, and that's going to be 3 times 250. So let's calculate that. We're going to go math number 9. We're going from 0 to 3. Whoops. Go to. Really messed that up. 0 to 3 of f of t, or y1. So variables y1 with respect to x. But we have to add in the 5,000. So we'll add 5,000. So 5,876. 5,877 if we're rounding. It says to the nearest gallon. Well, now we need T of 7. Well, at 3, we know we have that 5877, but I'll use the value in the calculator over there. And we're going to add on the integral from 3 to 7 of f of t dt. And we're going to minus out how much leaves, which changes. So we're minusing out this rectangle, which is 1, 2, 3, 4 times. And if we look at the other piece of the piecewise function, we see that's up there at 2,000. That's a 2. Well, we have this amount in our calculator, and we're going to add in the amount of water that goes into the tank. So number 9, and we're going from 3 to 7 of variables, y1, dx, and then we're going to subtract out that 4 times 2,000, or 8,000. So when t is 7, there are 5,264 gallons in the tank. And so let's answer the question. To the nearest gallon, what time t is the amount of water in the tank the greatest? The amount of water in the tank is greatest at t equals 3. I think this is hours. And there are 5,877 gallons. All right, let's do the next one. A water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. During the time interval 0 to 18, water is pumped into the tank at this rate. So this is enter. We might want to make that note so we don't have to read back through. During the same time, the water is removed at this rate. And we want to make a note, or at least realize that they're talking about rates, not how much, but a rate. Is the amount of water in the tank increasing at time t equals 15? So A is the amount of water. So the overall rate is equal to W of t minus R of t. So that's the overall rate of the amount of water in this tank. Is the amount of the water in the tank increasing or decreasing? So A of 15 is equal to W of 15 minus R of 15. And I put the functions into y2 and y3, but that's not going to do us a whole lot of good if we're evaluating. So we'll just do this by hand. We got 95 square root of 15 times the sine of 15 divided by 6 squared. And then we'll minus out R of t, which is 275 sine of 5. And that's also squared. All right, so the rate at 15 of overall in the tank is going to be negative 121. So negative 121.090. What does it say? Is the amount of the water in the tank increasing at time t? Yes. Why or why not? Because A of 15 is equal to negative 121.090, which is less than 0. So the rate is negative. So that means overall we're losing water. So B, to the nearest whole number, how many gallons of water are in the tank at t equals 18? So is there an initial value? Yeah, the initial value is 1,200. So we have 1,200, and then we're going to go plus the integral from 0 to 18 of A of t dt. So let's, and I already put the function, I'm going to turn this one off. The W of t is in y2 and the R of t is in y3. So let's go back here. Let's go 1,200. Whoops. 1,200 plus math number 9 from 0 to 18 of y2. I gotta remember to do y2 here. y2 minus variables, y variables, function minus y3 with respect to x. So the amount is 1,309. Actually, 1,000. Am I rounding to the nearest? To the nearest whole number. So we have 1310 gallons. Letter C. At what time T for 0 to 18 is the amount of water in the tank at an absolute minimum? Show the work that leads to your conclusion. Well, here we have to graph these. So let's, I've put them into Y2, Y3 already. Here's the window that I needed to use to see the entirety of both of the equations. So we're going to graph this. Here is entering. This is the W of T. And then we're going to see R of T. And we can see two intersection points. Actually, probably three, I think. I think it's maybe hitting 0 at 0 and 18, but we have two intersection points. So let's go second, calculate. We're going to get an intersection point. First curve, second curve. Let's move back over to where we think the intersection is. So we're going to look at T equals 6.4948402. Let's get the other one. We're going to calculate an intersection. And I suppose this is where it's going from positive to negative. This is probably the one that we want. Second curve, yeah, that's sure. The other value is T equals 12.974825. So what are we trying to do? At what time T is the amount of water in the tank absolute minimum? Show the work that leads to your conclusion. So let's look at T equals 0. And we know that's 1,200. So 1,200 gallons here. T equals 6.4948402. T is equal to 12.974825. And then we'll go T is equal to 18. So we're checking the endpoints also. Well, we already went to 18. We already have that one. So 1,310. So we have two of them. We just need two more. Let's go here. And we can go grab this right here. We'll grab this value. And we just need to change this to that 6 point, see if I can read my handwriting, 4948402. So we'll see how much is in here. This should be maximum maybe 425.2421528. And then we'll go grab this again. And we'll change this value. 12, right? 12.974825. 974825. Yeah, that looks right. Waiting for the calculator. 1,697.441. That's the winner so far. Oh, and it is definitely the winner because then this was the 1310. Now, does it say round to the nearest show or at least the amount of water tank absolute minimum? So let's go. It doesn't say round to the nearest, so we're going to go 3 decimal places. So 1,697.441 gallons. Letter D. For T greater than 18, no water is pumped into the tank. But water continues to be removed at the rate R of T until the tank becomes empty. Let K be the time at which the tank becomes empty, right? But do not solve an equation involving an integral expression that can be used to find the value of K. Well, we want to know when the integral from 18 to some value of R of T, well, the tank will be empty when we've removed the 1310, because that's how much we had when at T equals 18.